Hello everyone, and welcome to the Natural Language Processing Project Solutions lecture. In this lecture, we're going to begin coding out the solutions for the NLP project. Let's go ahead and jump to the Jupyter Notebook to get started. Alright, here I am at the project notebook, and I'm going to go ahead and jump right in. First thing you have to do is import, and I just said the usual suspects, so hopefully by now you're always importing pandas as PD and NumPy as NP. And then for visualization libraries, you can import those later on for the EDA section, or you can just import them now. You can say import matplotlib.pyplot as PLT, and then we'll go ahead and import Seaborn as SNS and set matplotlib inline. All right, then we wanted to read the yelp.csv file and set it to a data frame called yelp. I'll go ahead and do that. We'll say yelp pd.read_csv, and the trick here, you can just start typing in ye, click tab autocomplete, and if it's in the same directory, this will go ahead and find it for you. Let's go ahead and check out the head, info, and describe methods on this Yelp data frame. First off, just checking out the head, I'll go ahead and type head equals 2 as the argument so I can only see 2 rows. Looks like we have a business ID as some sort of string value, the date of the review ID, and then we have the amount of stars that was rated, the text of the ID, the type of whatever this row is, in this case it's a review, the user ID, and then how many people said it was cool, how many people said it was useful, and how many people said it was a funny review. Let's go ahead and check out the info for this. We can say yelp.info, and we have 10,000 entries, so this is a good amount of data to work with. And take in mind that it's actually not using that much of our memory. It's a small file, but as far as the number of entries, we do have a substantial amount to work with. And then we can check out as well the describe method. So we can say yelp.describe, and you'll see something that looks like this. And the only numerical columns here are the stars, cool, useful, and funny columns. Now what we want to do is, just like we did in the lecture, we want to create a new column called text length, which is the number of words in the text column. We'll go ahead and do that using apply. So I'll just say yelp text length is equal to yelp text, and then I'm going to just apply len, the built-in length function. Now what we want to do is some exploratory data analysis. You can import the data visualization libraries if you haven't done so already. We actually already did that, but one thing I'm going to do is set the style for Seaborn. And I'll just have it be white. But you can go ahead and not set style, doesn't really matter. Next thing, we wanted to use the facet grid from the Seaborn library to create a grid of 5 histograms of text length based off of the star ratings. And we wanted to reference the Seaborn documentation for hints on this if you need them. But hopefully, you feel comfortable with using facet grid. It's kind of a two-step process. First, you have to actually create the facet grid by calling sns.facetGrid, and I'm going to set it equal to this variable called g. Pass in my data set, and then I want to say the columns are going to be equal to stars. And if we look at this example output, we can see stars 1 through 5 is the column for each of the histograms. Okay, and then we can go ahead and map plt.hist, and we'll go ahead and just do this with text length. All right, and there we have the actual histograms, and you can continue adding arguments here, such as bins is equal to 20, so you wanted to get a little more detail. Since we have so many rows, let's go ahead and set bins equal to 50, and now we can really see some detail here. It looks like the distribution of text lengths seems to be the same for all of the number of stars. It looks like the actual amount of text reviews seems to be skewed a lot higher towards 4 and 5 stars. So that may cause some issues as we go along throughout this process. Let's go ahead and create a box plot of text length for each star category. Again, Seaborn makes this quite easy. We can just say SNS box plot, pass in x is equal to stars, and y is equal to text length. Our data source is just that Yelp data frame. Let's go ahead and run this. And if you want, you can change the palette the palette I used in the solutions was rainbow, just because I think it looks a little nicer, but again, this is totally optional. And here we have the box plot. And just based off of looking at this box plot, who knows if text length is actually going to be that strong of a feature. It appears that 1 to 2 star reviews have higher text lengths, but there's so many outliers shown by these dots outside of the bars of the box plot that it may not be a useful feature. Let's go ahead and create a count plot of the number of occurrences for each type of star rating. And this is going to basically reflect what we saw in the histogram earlier. In order to do this, we can just go ahead and say sns.countPlot. Pass in X is the stars column. My data source is that Yelp data frame, and I'm going to go ahead and set the palette again to rainbow so it looks a little nicer. And here we have that count plot. And like we saw in the histogram, if we go ahead and jump up, we saw that we had higher amounts of 4 and 5 star reviews, and this is reflected in the count plot as well. What we're going to go ahead and do is use group by to get the mean values of the numerical columns. And you should be able to create this data frame with the operation. So here's the data frame we're trying to create. And it's actually pretty straightforward. So I'm going to just say a new data frame called stars, say Yelp group by, and I just want to group by stars, and then call mean as the aggregate function. And we'll go ahead and just display stars to show it. And that's how you can create, using group by and then an aggregate function, the mean values of these numerical columns. Let's go ahead and use the core method on the group by data frame to produce this data frame. So that's actually quite simple. You can just say stars, CORR, call the correlation method on that, and now you can see how correlated the actual columns are to each other. So cool is how correlated it is to useful and funny versus text length, etc. Then we can use Seaborn to actually create a heat map based off of that. So again, that's quite a simple step. You say SNS heat map, pass in stars.corr, get our C map. You can go ahead and just call this cool warm if you want, or you can just use the default. And I'm going to set annote equals to true so we can actually see the numerical values. All right. So looking at this, it looks like funny is highly correlated to the useful value, as well as useful being correlated to text length. And obviously we see a perfect correlation along the diagonal, which makes sense because text length is perfectly correlated with itself. And it looks like we have some negative correlation between cool and text length funny and useful. That's an interesting note, but you'll probably need more business domain knowledge of how people actually use the cool, useful, and funny review features in Yelp to actually get some sort of intuition or sense of what that actually means. So we'll go ahead and just leave it at that for now and move along to the NLP classification task. To make things a little easier, go ahead and only grab reviews that were either 1 star or 5 star. We'll just go ahead and drop 2, 3, and 4. So create a data frame called Yelp class that contains the columns of Yelp data frame, but only for the 1 or 5 star reviews. So I'm going to create a data frame called Yelp_class and set that equal to Yelp. And then I want to filter out by 2 conditions where Yelp stars is equal to 1, or with the pipe operator. Remember, you can't use OR here, otherwise you'll get an ambiguous truth series. And then we'll say Yelp stars is equal to 5. And now if we check out Yelp class info, you'll notice you get now about less than half of the columns, 4,086. Okay, moving along, we want to create 2 objects, X and Y. X will be the text column of the Yelp class, and Y will be the stars column of the Yelp class. And these are just our features in our target variables. That means I set X equal to Yelp class, the text column, and then I set Y equal to Yelp_class, the stars column. And I'm going to import count vectorizer and create a count vectorizer object. And remember, I say from sklearn, dot feature extraction dot text import count vectorizer. And then to make an object, call for the count vectorizer object, just going to call it CV and instantiate it just like we would for any other model. Then I'm going to use the fit transform method on the count vectorizer object and pass in X. That's the text column. And I'm going to save this result by overriding X, which basically just means I need to do this. I'm going to set X equal to CV dot fit underscore transform X itself. Okay, now what we're going to go ahead and do is split our data into training and testing data. So you can use train, test, split to split up data into xtrain, xtest, ytrain, ytest. And then use test size equals 0.3 and random state 101. I'm going to go ahead and import from cross-validation, sklearn.cross-validation, train, test, split. Run that. I'll start typing train, test, split, just using tab autocomplete here. Shift tab, expand the documentation and grab the useful example line so I don't have to type this all out. I'll go ahead and grab this and then replace it here. I'll fix my test size to be 0.3 and random state to be 101. Let's go ahead and run this, make sure it works. Looks like it did. And now it's time to train a model. We're going to import multinomial NB and create an instance of the estimator and call it NB. I'll say from sklearn naive Bayes import multinomial NB and set an instance of it to NB multinomial NB. And now I'm going to fit NB using that training data. So nb.fit xtrain ytrain. So I have my multinomial naive Bayes model trained, and it's time to see how our model did, predictions and evaluations. We'll go ahead and use the predict method off of this NB object that I just trained to predict labels from xtest. Which means I'll make a variable called predictions, and I'll just say NB predict x underscore test. And we'll go ahead and create a confusion matrix and classification report using these predictions and ytest. Which means from the sklearn metrics, I'll import both confusion matrix and classification report. Run that, and I'll go ahead and print the confusion matrix, pass in my test data, compare it to the predictions. I'll go ahead and print a new line, and then I'll do the same thing, but now with a classification report. I'm just using tab autocomplete here, ytest, and then predictions. We can run all that, and we see our confusion matrix and our classification report. Not too bad. We're looking at around 90% accuracy, precision, and recall between the 1-star and 5-star class, just totally based on the text data. So that's pretty cool. And let's go ahead and see what happens if we try to include TF-IDF to this process using a pipeline. And it may not be what you expect. We'll go ahead and import TF-IDF transformer from scikit-learn. And that's also under sklearn feature extraction .text. We'll import TF-IDF transformer. We'll import pipeline from scikit-learn. So that's from sklearn.pipeline import pipeline. And now we will create a pipeline with the following steps: count vectorizer, TF-IDF transformer, and multinomial naive Bayes. In order to do that, we'll just go ahead and set an object. I'll call it pipe. We call a pipeline, and then you pass in a list of tuples. And remember, the tuples have two elements in it: the name of the process, and that's totally up to you what you call it, and then the actual model you're going to pass it through. So we'll start off with a count vectorizer. The next thing we'll put in is the TF-IDF. So remember, the count vectorizer, that turns the strings to token integer counts. That's just essentially our bag of words. Next thing we're going to do is TF-IDF transformer, close parentheses. This is the integer counts to weighted TF-IDF scores. And then finally, if we go ahead and put in one more, what we will do is train on the TF-IDF vectors with naive Bayes. So I'm going to say, let me make sure my parentheses are matched up here. So this needs one more closing parentheses. This tuple's good. And now I need one more open one here. Okay. So we'll just call this the model or classifier, whatever you want to call it, multinomial NB, close parentheses, and let's make sure that ran correctly. I believe I need an extra comma here and actually have unbalanced parentheses. Let me fix that and run this. Okay, great. Looks like our pipe's working correctly now. Keep in mind these parentheses are kind of hard to balance sometimes, especially since you need closed ones on the model, so just pay careful attention to that. Now let's go ahead and use this pipeline. Remember, this pipeline has all your pre-processed steps in it already, meaning we'll need to resplit the original data. Remember that we overwrote X as the count vectorized version, and what we actually need is just the text. So I'm going to go ahead and redo that train test split on the Yelp class object. Meaning I'm going to go ahead and set X again to Yelp class text, Y to Yelp class stars. Okay, then we need to do the train test split. I'm going to go ahead and just grab it from where we did it earlier. And that was up here under train test split. I'm going to do Control A, Control C, or Command A, Command C, depending if you're on a Mac. Come back down here and then paste it with Control V or Command V. Let's go ahead and run that, make sure it works. Looks like we're good. And now we will fit the pipeline to the training data. And remember that you can't use the same training data as last time because that data has already been vectorized, which is why we need to pass in just the text and labels, which is what we did here in this step. Just want to make that clear for you. We'll go ahead and say pipe.fit to xtrain and ytrain. Run that, and it went ahead and fit it. It did a count vectorizer, and then it went ahead and did the TF-IDF and the multinomial model. Now let's go ahead and do predictions and evaluations. We're going to use the pipeline to predict from the X test and create a classification report and confusion matrix. So I'm going to say we'll go ahead and just overwrite predictions. We'll say predictions is equal to pipe.predict on X test. X test with an S. There we go. And let's go ahead and then we can actually just copy and paste what we have up here. Let's go ahead and copy that. Control C. Paste it here, and we'll get an interesting result when we run this. So notice what happened when we actually included the TF-IDF. It looks like TF-IDF actually made things worse. So that's actually where we're going to end this project because I want you to actually on your own see if you can explore it. We did a pretty good job just using the bag of words model, and this is pretty acceptable depending on what the application is, but a 90% accuracy and precision and recall on just text data it looks pretty good. It's not exactly state of the art, but it's pretty good given how easy it was just to run a couple lines of code. But what I want you to do is actually explore, see if you can do some feature engineering, go back, play around with the pipeline steps, and see if maybe creating a custom analyzer like we did in the lecture helps. And a quick note, it probably actually won't, but go ahead and explore that. Or maybe recreate the pipeline with just the count vectorizer and naive Bayes. And I also want you to check out and explore this changing the actual machine learning classification model at the end to maybe another classifier actually help at all. Okay, great job. Hope you enjoyed the project. Again, there's a lot more you can dive into for natural language processing, so I really encourage you to check out the resources shown in the Jupyter Notebook. Feel free to post any questions to the Q&A forum. Thanks everyone, and I'll see you at the next lecture.